Hi there, so my name's Jon Hammant. I come from a company called Epam Systems that I would imagine very few people in the room have heard of, other than our TA sitting at the back, which is good. So I'm head of DevOps and Cloud for UK and EU for Epam Systems. Here to talk to you tonight about the ELK stack and specifically around some of the Beats plugins and some of the concepts around monitoring and metrics, and maybe tell you some things you guys don't know or refresh what you do. So, as my email address, feel free to email me. We are hiring at the moment, so we're expanding quite a lot into Europe. So if you're looking for a DevOps role, in London, we have bases all around the world, so we're in around 100 countries or so. So please come and talk to us. We've got about 20,000 employees at the moment, and we're aiming to break 2 billion in revenue this year. So come along, and that's enough for our stuff. We are doing some very interesting things. Docker, we're doing quite heavily. Internet of Things, we've got a VR team, and we've got a cryptocurrency team who are working on things at the moment. So, problem. So there is a husky in a tree, which isn't the problem, but the problem that we have is we have too many systems at the moment, and there's not enough visibility to it. So increasingly, the world has become more microservice oriented. We massively distributed systems. You know, you have huge amounts of log coming through per minute, and there's this increasing number of microservices that's growing, and increasingly sitting on cloud native platforms. So there is no central point where effectively you can log to. So, you know, what do? You've got options within it. You can just sit, put your head in the sand, and you can, you know, pretend that it's not going. You can look at the Netflix model of, it doesn't matter, it falls over, you know, we'll all pretend it's all okay. The reality is, you all need logging and metrics, and it can be done well, and it can be done scalable. Running through the ELK stack, it's a lovely piece of technology. So you know, you can really run it up in a couple of hours, 2 to 3 hours, I reckon, to get it installed, running on a native system. And if you're using one of the cloud-hosted solutions, such as logs.io or the Elastic Cloud, you're talking 10 minutes to get it running. So you can do this, and you can do it very quickly. And so hopefully, why do we need metrics? And you know, there's a view at the moment of maybe we don't need to look at this stuff. Maybe we can just leave it running and, you know, not care. But we can deal with just our syslog daemons and grep, which I'd imagine quite a lot of you are using. But there's a very good reason why. So think back the last 2,000 years. So what would anyone think the most popular medical procedure had been? And amazingly, it's bloodletting. So for 2,000 years, we had people regularly bleed people. So they would come through. Came from Gaians in the Greek times, started through, and it was done for all manner of illness. You know, it was a matter of, you had a headache, bit of bloodletting. You know, you had pain in the leg, bloodletting. You look back there's a really interesting story in the French military. So we had a guy who injured in battle. He lost some blood, fainted, came back, and over the next month, he had 13 pints of blood removed from his body over a month. And that seems like quite a lot to me, but, you know, the reality is at the time, it wasn't being done harshly, it wasn't being done through stupidity. It was done because people cared. People would have bloodletting on their children, they'd have bloodletting on their parents, you know, it was the thing. And the real reason none of this continued for so long was because we didn't have metrics, we didn't understand what was happening, there was no scientific method behind it. And the lovely thing that all of us within this room, we all take part in a science. So, you know, computer science and empirical science, we can get information out and we can understand what's going wrong and why. And I just want, you know, think about it. When you're losing information off your servers, the same thing's happening. You're bleeding out information that you're never going to get back. And unless you keep that and you run through and you understand what's happening, you will be making mistakes. And this happened for 2,000 years, so I can assure you that there's things that you're doing at the moment that don't work and shouldn't be done. So why ELK? So there's a lot of other stacks on the market. So there's Splunk, which is very, very good, so I completely agree with, but it tends to be very expensive. So one of the things around Splunk is you previously did last time we explored it, you basically charge for the amount of data, which, you know, I'm saying log everything, log all the data you have. And if you're charged for the amount of data, obviously that's not a very good way to do it. So that's why ELK comes into its own. So ELK itself is Elasticsearch as a backend, basically Apache Lucene with Java running on top of it. Logstash, which is a log enrichment engine which sits on top, which used to have, before version 5, used to have a lot more presence with the Logstash forwarder. And then Kibana on top, which is a lovely graphical user interface that gives you all the power of raw calls into Elasticsearch, and nice and graphical UI. And it scales extremely, extremely well. So all of Foursquare's search is currently running on Elasticsearch. All of GitHub, every time you type and you search for code, that's going through Elasticsearch again. And the lovely thing, as I said before, it's really quick really quick to get up and running. So I reckon 10 minutes for a cloud-hosted version. So that's it. But it's not, because obviously this would be a very short talk if it was. So we haven't logged all the things, because at the moment we have this lovely logging stack that's sitting there, and we have information on all of your clusters and all sitting around, but it's not getting into the central host. And one of the problems traditionally with monitoring is if you think of how that data comes across. So if you're just going to go for, unplug that. If you're just going to think of a traditional format, you just look at text files, syslog, rsyslog comes across. But it's quite a heavyweight way of doing it, and you don't want to have syslog running everywhere. You don't want to have forwarders running within the containers. Docker has the mantra of, you must have one process running per container, even though I'm guessing most people don't. So we don't want to do that. And more than anything, you don't want to spend your days writing logging code. There's no benefit to it. It's easy stuff. It's stuff that's repeatable. It's stuff you don't want to do. So then let's not do it that way. So this is where the Beats plugins come in. And I think they're really nice, actually, the way they've separated them out. So it was launched in version 5 of Elasticsearch, and I like the first thing, they are single-purpose, lightweight data shippers. So the idea being that you have them for different uses. So you may have one to do one thing, one to do another, and you have very singularly focused data shippers that sit around your different microservice applications. Well, I forgot. They work extremely well with microservices. So they're designed to sit alongside, so you can run them either on the container host, you can run them within the container. Logstash is still important in all of this, so Logstash still sits in the middle, or can sit in the middle if you so wish, and that can do the data enrichment and reformatting. And for enrichment, because it's one of these weird topics, people don't quite know what it's doing sometimes, it can do things like GeoIP lookup, for example, or it can strip out, if you have a whole bunch of IP addresses that you're sending to it, you don't want to send IP addresses, you want to send host names. So you can process this all through, you can process this all through Logstash itself. Also, everything goes through the rest of the Elasticsearch stack, so you can use ElastAlert or anything along that you would like to. There we are, perfect, thank you. See, if we were logging this, we would know exactly who was doing it. So these are the 4 core beats that come with it. So these are all produced by Elasticsearch. They're very battle tested. You can scale out. You can pretty much drop them on your production cluster without much difficulty. Obviously, do test anything before you put in your production cluster, because that would be very silly otherwise. So firstly, we have FILEBEAT. So FILEBEAT's probably the most familiar for a lot of people. Really what it does is it takes one file and it sends it into the central Elasticsearch cluster. It's kind of, from a Unix way of things, it's kind of cat on steroids, so it's piping the file off, returning it somewhere. It's nice and easy, it's easy to understand. But the really key thing about it is that it has this concept of back pressure. So if all of a sudden you're sitting there, you have a really busy day coming up, you're selling lots of things, and widgets are selling away on the website, all of a sudden you have this spike of pressure, a spike of logging information coming in, it will slow down and it will reduce the rate that it's sending it to the central host. And that's very, very important, because the last thing you want is, you want logs to catch when things go wrong. So you don't want your logging infrastructure to go wrong when everything else is going wrong. And it's a very, very important thing to know, because it's difficult to test. Oops. Let's skip forward. So actually, I know why it's doing that. Apologies. So MetricBeat. So MetricBeat is another plugin, but it's slightly different from FILEBEAT. So it gives you system level monitoring. So it's kind of like a distributed top is the easiest way to say it. So as soon as you install it, You get per process statistics on everything you're running instantly. And it's a very, very powerful thing. So, you know, one of the common things will break. Someone will turn around and say, was the daemon running? Was the application up? And most of the time, you can kind of look through SOA, you can look through log files, but you don't really know. With this, straight away out of the box, you can see that it was running, you can see that it was there. It's got modules for common services, so Apache, Nginx, there's a whole host of them as well, and it understands the performance counters that are inherent within the applications. And it's container ready, so you can deploy one copy of it, you can monitor everything else from your Docker containers if you permission it correctly. There's actually a slightly easier way that we'll go into just a little bit later in the presentation that I think personally, as a starter for 10 is better, but you know, the key thing is you can install this on your fleet now and straight away get information about what everything is doing in, you know, the time this talk takes. And this, for me, is something that I had never seen to this degree. So PACKETBEAT is a distributed packet capture, and it is flipping fantastic. So effectively, if you've used TCP dump, if you've looked at logs, you know, you sit on there, you run through a TCP dump, switch it on when stuff's breaking, switch it off when it isn't. What PACKETBEAT gives you is the ability to log all network traffic onto a box at any time, record that back to a central host. And you know, you're thinking, okay, that's lots of data, and that is lots of data. But you know, we live in a world where, you know, my phone's got 256 gig. The data is cheap now, so the ability to understand what's happening is absolutely fantastic. And it can understand different application layer protocols. So, common way of getting data out in a cyber attack at the moment is data exfiltration via DNS, which is a lovely ring to it. And effectively, that's by sending DNS, all the data, and doing a VPN tunnel through DNS. And you can straight away pick that up. You can see the amount of DNS queries, and it's fantastic for security and latency analysis. You know, it really is something you should be using. If the data's not useful, chuck it away. It doesn't matter. And then finally, WinLogBeat. So effectively, this is the one I'm not as interested in, I'll be honest with you, but that's more me. And that's monitoring of Windows event logs. It's very good. If you run Windows and you have a nice mix of systems, then I'm sure it's a good thing. I'd go to Unix personally, but yeah, it's just me. So, when logging and metrics works, we've talked about all of this, and you're thinking, oh, bloodletting, you know, that's not relevant now. No one does any of these things anymore. So what about an example of when this does work and when this is happening now? So I'm going to talk about something, and I promise you it will not ruin the film, because I kind of give away the ending, but you probably know what it is. So I'd imagine you know the ending of this, and effectively you had a pilot, he landed on the Hudson, really absolutely fantastic thing, fantastic stroke of genius. And he said probably one of the best quotes I've ever read in my life. Everything we know in aviation, every rule in the rule book, every procedure we know because someone somewhere died. We have purchased at great cost lessons literally bought with blood, and an extra have in there, but that wasn't in there originally. And yeah, the whole point of this is by the data that's been recorded on flights. It saved people's lives. And at the moment, okay, we are going into this Internet of Things world, connected computers, and the data that you record out fundamentally can save lives. So it is important, and it does work. You can see with the black box flight recorder how metrics have improved it. You know, flight has gone from, in 1926, there was 1 fatality per million miles, and now there's 1 in every 2 billion. So that's a 2,000 times safer in 90 years. And that's, okay, you can say autopilot's what it is, but it's not. It's the data that's done it, and that's the key thing. It's the data that changes things. So back to more of the real world. So community beats. So you can write your own beats. They're all really nicely extendable. Everything's based on a Go library called libbeat. At the moment, there's over 34 currently created. GitHub URL, which you can all use. And if you write any, you should add them on, because it's a very good thing to do. It's easy to set up. There's a nice generator for it. You can kind of do it in an afternoon, if you're okay with Go. And some of the highlights. So there's some very, very good ones out there. So you have HTTP beat is very nice. So that can poll a HTTP endpoint. It can also do some quite clever things. We've used it before. So you could poll your Jenkins endpoint or your Slack channel if you really wanted, and you could start pulling that into this lovely single source of information. MySQL beat. So query arbitrary queries on a MySQL server, you know, work out how much money you're making and try and start to pull some of this metrics back, not just to the infrastructure, but to the business value and to what people are actually making out. Because that's where it really matters. And it's lovely having the infrastructure, but actually being able to turn around and say to the CIO or the CTO, this has been the usage, this is what we made. That's that's where you have to go to. ExecBeat, periodically run commands, nice and simple, and there's a few others on there, so CloudTrail, PingBeat, ConsoleBeat, and I'm sure you can guess what some of those do. And just to show how easy it is, so this is DocBeat, which is a Docker-specific beat. So literally in 1, 2, 3, 4, 5 commands, and at that point you point it towards the central server. Straight away it begins monitoring your Docker cluster. It can tell you what images have come up. It can go back and it can, effectively you could look at security issues. There's so much capability, and it can tell you what's run, where, what CPU is used. And you can do that in, 5 minutes or so. So here's an example dashboard for people that haven't seen Kibana. It's really nice and easy. This is CPU usage on one machine. You have multiple hosts down here. This takes all of 2 minutes to get running. And you can also go to a point where you monitor it. If usage goes above, you can alert. It's absolutely fantastic. So that's almost the end of it. So I suppose it's what do you use it for? So you can run through discovering historic CPU usage, finding out where things run, the metrics that you have, what's going on with it. And it's extremely, extremely powerful. I think the most powerful thing of all of this is I cannot stress enough how distributed packet capture can change any of the issues you have, because the ability to sit back and say categorically, that site wasn't down, here's the packet capture, here's that specific IP going to it. We've been doing some stuff as well with AuditD. So AuditD, AuditCTL. So you can get audit events and you can pipe all of those back into syslog. So the ability to turn around your cluster and say, right, I can tell you specifically how many times TCP connect syscall was made over your whole cluster. And that visibility is absolutely fantastic. And you can do that now with technology that's there for free, or well, for free otherwise than hardware. So that's it. So at this point, we're hopefully logging everything. We've done it like the little fat kid. And it comes down to this view of storage is cheap. Record everything, chuck away the data later, but record everything at first and filter back through, because you have the bandwidth, you have the storage, you can do it, and it's worth it when you actually think of the business value that you get back from it. Pull it back to business metrics. And the important thing is just think of black boxes. If we hadn't had black boxes on planes, or if you look at the terrible thing that happened in Croydon recently, where they go back to the black box, they understand what's happened straight away. And that's the key thing to remember, that unless you're monitoring it, unless you're logging it, you can't learn from those mistakes. And you may be the one sitting in there in 5 years thinking, well, I've just been bleeding myself because I thought it was a good idea and it seemed like it made sense.